Thank you so much. My name is Chad. I'm going to be talking about the idea of responsive component design today, and hopefully leave you with a new outlook on how you can build some responsive components in your applications. You can find me on the internet as Chadian on GitHub, Twitter, Discord, and most things. And I'm currently working at Heroku, working on the front end and also working on the CLI, building lots of fun stuff. And I want to give a shout out to my team at Heroku just for being so supportive and encouraging for me giving this talk today. And also speaking of Heroku, right after me, Sama will be talking. So she works at Heroku also. So that's going to be a great talk. So you're going to want to see that. On that note, I also feel quite lucky to be part of the Ember community. I moved from Canada to Portland to Berlin and now New York. And each step of the way, I've found a very friendly Ember community. And it's really cool to see so many familiar faces in the audience. So thank you. So while we will be talking about responsive components in this talk, I want you to focus on the main idea of layouts and working within their boundaries. It's something that has always existed as we've created visual content. And I also believe that it's fundamental to the challenges that we face in creating responsive experiences. So up until fairly recently, layouts were actually made by hand. A few weeks ago, my girlfriend surprised me for my birthday, and we went to a print shop in Brooklyn where I got to learn firsthand how difficult making layouts by hand can actually be. So this particular technique uses something called movable type, which is individual letters that are made out of wood or metal, and you can string them together to compose words or sentences. And in this case, you first have to go and pull out this case and find the right typeface and font size that you want. And then you end up having to hunt for each letter individually. And hopefully there's enough letters that are available for what you actually want to say. After that, you end up arranging your type, making sure that everything is perfectly laid out. You have to grab one of these rulers, and you have to figure out how much space you need to account for, and then you have to fill that space in with these blocks. Once everything is perfectly laid out, you can tighten everything down, and you're ready for the presses. So on this particular press, positioning the paper has to be absolutely perfect. You end up tweaking these little pins until the paper lines up just perfectly to line up with the plate that's containing your letters. And when you're ready, you can pull the lever, and it'll press the metal plate against the paper, and hopefully everything works out. You'll probably end up burning through actually quite a few of these paper samples just trying to make sure everything lines up. And in this case, it worked, kind of. What ended up happening was that the paper actually wasn't big enough. So the pins that were holding the paper pressed into the letter E here, instead of pressing cleanly against the paper. And so what that means, I actually ended up damaging this particular E, because lead type turns out to be quite soft. And so when this pin pressed into the letter E, it's a permanent modification. So if I would have known about layouts and their boundaries, I could have maybe avoided this. And it's, these boundaries are nothing new. In fact, it was probably more important back then, as your mistakes could cost you hours of time or even damage your equipment. So I ended up actually having to throw out this letter E into a bin of other lead type that will eventually be melted down. And I would hope, and I would like to think, that one day this letter E will be melted down and become a brand new Futura 60-point capital E. We'll see. So while there have been incremental improvements in these kind of physical layouts that we've seen, it took desktop computers to really show us what was possible. Desktop publishing meant we could create our layouts and our content digitally. No longer did we have to rely on these physical tools. It was as simple as firing up a program, and then we could format everything quite easily with fonts, and then we could, when we were ready, send it to the printer. It was just sitting right next to us. So this process was much faster and much easier, and I think everyone would agree this is a much more enjoyable experience. But of course, I don't want to have to deal with papers and files. Information should move at the speed of light. With the invention of the internet and the browser, we could retrieve content around the world whenever we wanted. And the best part is that content could be updated live, and anybody could publish it. Sure, these computers are pretty expensive, but the distribution was easier, the tools were safer, and building layouts was much, much faster. I wouldn't blame you, though, if you looked at these initial designs and you would consider them a step backwards, even compared to maybe magazines from the 60s, 70s, and 80s. Like, this is kind of ugly, isn't it? And so in the browser, we forged forward. We tried to push boundaries. We used now hacky techniques to get things exactly where we wanted. We would use tables and table cells as a way of creating boundaries for our content. And while this kind of worked, I don't think anyone's arguing that this was the intended use of a table element. And with what felt like maybe a slow march of time, we started to get a taste of what was possible with CSS. We could use CSS properties like display, flow, and position, and we gained what we thought were superpowers, right? I mean, now we had style sheets, we could target elements, we could create rules and systems to position and place our content much more declaratively. And with newer tools, we could even develop better processes to handle our layouts. We could talk with our designers using a common language around fixed width grids. We had a sense of how space would be filled and what type of content would fill it. And before everything was done, we could drop some placeholder content and try to imagine the constraints of the layout. Nothing was set in stone, and we could iterate on our layouts and move things around as we see fit. And I think this was all really fantastic, right? I mean, I think what made all of this possible and all these tools possible was the fact that we were most often dealing with a container of a fixed width. Filling it was actually pretty straightforward. And maybe you're starting to see the pattern here. Sorry if this is a dull point. We have layouts and we have content. The content goes inside the layout, and it has to fit for everything to be in perfect harmony. And the story could have ended there, but then the iPhone was announced. Apple caught us by surprise. An iPod, a phone, and the internet in our hand, that's crazy. We tried to use our old layout systems in mobile Safari. All of a sudden, a fixed width on a screen wasn't good enough, even with all the gestures. Remember having to pinch to zoom or double tapping on the content to get to a particular section? And good luck trying to tap that link when you're not zoomed in. And what about hover menus? Browsing the web was kind of awkward, but I truly believe that Apple did a tremendous job in making it work. So in 2007, the iPhone was announced, and we lived with that cumbersome experience of desktop layouts on a phone until 2010, when Ethan Marquette solidified the concept of responsive web design. We were all encouraged to make our content and layouts respond to the screen or the viewport they were on, and we wanted mobile first without compromising the experience for people on their phones, tablets, or desktops. You might remember responsive websites taking off. If you worked at an agency at the time, everyone was trying to figure out the best way to make for a mobile-first experience. Some would try using tools like Bootstrap, and this would work as long as you followed the conventions and used their CSS classes, while others would try to tweak media queries for individual pages, offering bespoke tweaks for the exact specific content on the page. And all of this was definitely a step in the right direction. Finally, entire pages could be designed and fitted to be responsive. Many of you know that responsive web design was powered by media queries in CSS and the corresponding JavaScript API match media. With these powerful tools, we were able to build a new set of processes, tools, and provide the best experience for our users. It wasn't long after this that we started to see the rise of JavaScript frameworks. It didn't take long before markup was off the server and being hot rendered by JavaScript in the browser. Thanks in large part to the React project, we started to see the value of the component as a primitive. And this meant that it became more and more important that we be able to drop these components anywhere within our layouts. Let's take a look at this example. Here I have a greeting component, and we're using that angle bracket invocation style that Godfrey just talked about. And let's imagine we wanted to reuse it in different places. Anytime we drop this greeting component somewhere, it should render consistently. By using arguments, we can treat the component as a black box and pass data into the component treating it like a renderable function. Here, our greeting component has a greeting argument that specifies what should show up in front of the word world. When the component is rendered, it replaces that marked placeholder of the argument with the value that we've passed in. If we were to pass in the word hi for the greeting argument, we would consistently see hi world. Now, this is a long example, but it's really just to show you the beauty and the importance of the component boundary. We know that whenever we respect this local boundary and avoid global state, possibly injected by Ember services or through module imports, that we have a component that is easier to reason about, maintain, test, and use. But how do our components fit in a responsive world? How can we handle a situation where we need different sizes of components? Maybe we could extend our example and add a size argument to our greeting component. In this example, I have the 3 different sizes. You can see that there's a size argument on our greeting component. If I pass in an L value, I get a large component with hi world with the hand emoji. And then we drop the hand emoji for the medium component, and then small is just the main greeting argument there. And for many of you to wire this up, maybe you would have used ember-responsive. Ember-responsive behind the scenes is using that match media JavaScript API that I mentioned. And with this, we can determine when conditions have changed, for example, a change in the viewport width or the height. And then we can use the service and respond accordingly. So let's imagine I've configured ember-responsive with these 3 breakpoints, mobile, tablet, and desktop, and we want to map these in a computed property that tracks those changes. So in our computed property, we have, for a mobile breakpoint, we'll receive an S value. For a tablet breakpoint, we'll receive an M value. And for our desktop breakpoint, we'll receive an L value. And visually, that looks something like this, just to kind of help those that are maybe visual learners. You can see that on the desktop breakpoint, we are passing in an L value into our size argument, and that gives us this large component. Similarly for the medium component on a tablet breakpoint, and lastly, the small component with the S being passed into the size argument for the mobile breakpoint. And let's take these components that we have and look at them, and they work. For months, they're sitting in production and happily doing their job, and everybody on all the devices are using them, and things are good, and everyone's happy. But then one day, maybe our product manager comes to us and says, well, with all that space on the desktop, wouldn't it be nice if we had a 2-column grid? This would let the user choose if they want a 1-column or a 2-column. If we have 2 columns, let's use medium-sized components. But if we have 1 column, let's just fill that with a large component. Again, that looks something like this. So we'd have 2 columns, and instead of large components on the desktop, we'll have medium components by passing in that M value into the size argument. So we go ahead and we update this mapping in our computer property, and we say if we're on the desktop and we have columns, we'll show medium-sized components, and if we're on the desktop and we don't have columns, we'll show a large component. And the rest of the mapping in this computer property stays the same. But over the course of time, our varieties grow. On desktop, maybe we want 4 columns with small components. With the 2 columns, we want those medium components. Otherwise, we'll use a large component. And let's not forget about the tablet breakpoint. Let's say we have 2 columns on a tablet, and we want to show small components for that, otherwise medium. And luckily for our mobile breakpoint, we can just leave everything the same. Whew. All right. So what does this mapping on our computer property look like now? Maybe this is still doable, but our components are defined to this mapping. And it's a mapping that's based on a global environment and global breakpoints, right? Our components started off responding to the size of the device or viewport. But in reality, our components are placed in any number of layouts, and keeping track of how they should look under changing conditions becomes increasingly difficult. As the space inside of our layout changes, so should our components' ability to react to the boundaries and their local environment. And this is where container queries come in. You'll also see them on the web as element queries. And the idea is that a container should be able to respond to the size and the space it's been given, independent of the viewport or screen. This way, we can tweak the content that's shown, so we're always representing the best version of the content with the space available. In fact, this isn't really a new idea. Ethan Marquette has chimed in, and he's a big fan of the idea. He's mostly been talking about a CSS-based solution, but many people have been playing with the JavaScript version of the idea too. Now, I want to take a quick moment and show you what this could look like in Ember, and I just want to reiterate that no media queries were used in the making of this demo. Okay, let's see if I do this right. Yeah, that's right, actually. Okay, let's make that big. Okay. All right, awesome. I guess I'm going to do this way. Scrolling work? OK, there we go. All right, so we have some components here. We have a weather component, we have a GitHub card component, and we have a article component. Oh, and there's also this volume component at the bottom here. And you can see that we have the full width of the screen, but within this dash border here, we actually have a container. And as we change the size of the container, you'll see that more and more information pops in, right? And another interesting fact about this is that you'll notice that the size of the font is also changing. So you might have used responsive typography before by using viewport width units, but with this you can actually also do it based on the width of the component. And yeah, as the size changes, everything fits based on how much space is available. And that's the generic idea. Similarly, with this GitHub card component, we start off with a very narrow component, and it's in a vertical format. And then at some point, we're going to hit this breakpoint, and it's going to snap to a horizontal component that is more friendly for a horizontal amount of space. Imagine a kind of desktop, or maybe a wide version of the tablet. And just to kind of show you that this also applies to all different types of components, not just widgets and cards, but also it can apply to content. And here I can make this bigger, and as it increases, the styles will change. And once I hit a larger breakpoint, you can see that there's much more space available, so you can take opportunity of different stylistic changes. And lastly, we aren't constrained to just moving by width in a horizontal. We can also move in a vertical way. So this component, as the container is getting bigger, it's reacting and showing the different. Yeah, I'm sure you can all see that. The other thing I wanted to show you was what this looks like within layouts. So here we have those same components, and we have many of them kind of stacked together. And you can imagine that this is a mobile width, right? And initially, everything looks really skinny and like what we saw before. But as I increase the width, we see the same effect that we saw before, right? Nothing new. But then as soon as we hit the second column, you can see that we're recycling those initial skinny breakpoints, because the components are now in a column that is narrow, which is confining it back to that initial kind of narrow width that we saw with the mobile breakpoint. So this is to show you that the components will work in the environment they're placed, and that means within different layouts, et cetera. And just in case you're wondering, none of these temperatures are actually accurate. They're just random numbers, so don't get freaked out about global warming, even though that is a thing. OK, so I mean, you should be freaked out about global warming, but not because of these temperatures. OK, so let's jump back to great. So actually, this talk, I guess, should have probably been called the current state of responsive component design, because all of this is possible today. It's just up to us to go out and use it. Container queries help reinforce this idea that components have physical boundaries, and physical boundaries are provided by layout. And like programmatic boundaries, these physical boundaries make our components easier to develop, test, and use and maintain when we use the container queries. We no longer have to worry about the viewport or the global state, because our components know that given a width or height available, they can display themselves in the best way possible. The add-on used in this demo is called EmberPhilip. I made it to play with some of the ideas around container queries. I wanted to explore what an ergonomic API could look like to build these types of responsive components easily. Now, some of you might be wondering, how do we actually detect these changes on the element? Behind the scenes, EmberPhilip is using something called a resize observer, and resize observers were actually created to allow us to respond to changes on an element independent of the viewport or width. And we've been waiting a long time for this, and we almost have it in all major browsers. Currently, there's no IE support, but there's a polyfill that you can use, and I intend on making public on the add-on the ability to use different size detectors. We can talk about that later. And also, when I say Safari here, it's apparently the most recent version of Safari that was just released, so apparently it's there. All right, so out of the box, EmberPhilip provides two main primitives. The first is an element modifier that you can place on any element, and when that element size changes, it'll tell you. And then secondly, we have a Philip component, which is a Swiss Army knife component, which is most likely what you'll end up using most of the time for most use cases. Let's start by looking at the element modifier. The idea of the element modifier, in this case, is to be as simple as possible. Here we registered the element modifier on a div, and we are passing in an onChange function. And this function will get called whenever the size of the element changes, and it will get called with the element that was changed. And once you have this element, you can actually pull the width and height off of it, right? And once you have that information, you can make any changes programmatically that you would like to react to these new width and height values. That's the element modifier, but most likely, most of the times you'll prefer using the Philip component. It's much more useful. But before we can talk about that component, we first need to talk about how we can define breakpoints. And these breakpoint definitions can be passed into the Philip component so that the Philip component can make your life much, much easier. Breakpoints are a collection of breakpoint definitions, and one way to define these is actually by using the template helpers. Here we're using a hash where the key is the name or the label of the breakpoint, and the value is the definition. I'm not showing you all the template helpers here, just for the sake of space, but you can check the documentation to see the entire list. But I think you can imagine kind of the extension of this. Another option for these breakpoint definitions is to use the definitions in JavaScript. These functional definitions mirror the same kind of API that you would expect from the template helpers. Here we're, again, creating a hash of breakpoints defined in JavaScript on the left, and then I'm able to pass it to my Philip component on the right. One advantage of this technique is that you can save a lot of space by pulling them out of your template and into JavaScript. And you can also imagine that you could export these, share them, and reuse them across a host of different components. So now that we've seen how breakpoints work, let's jump into 3 strategies of using the Philip component so all of you can create your own responsive components. First off, let's look at breakpoint selectors with CSS. This will most likely be the most comfortable for many of you if you're used to media queries where responsiveness is defined in CSS. In this example, we're using the Philip component within our greeting component, and the Philip component actually contains a div element that you can't see here. And everything in that Philip component's block ends up going inside of this root div element. And this allows us to track the changes on the root div element and apply the breakpoints as attributes. The root element in this case will be receiving the greeting class that we're passing in, and the Philip component will receive the 3 breakpoints, small, medium, large, with the respective conditions. Inside of our Philip block for this example, we're going to keep it simple, and we just have a greeting and a name. So continuing that example into CSS, we can see that in our style sheet, the breakpoints are reflected as attributes, along with that greeting class that we passed in. So by default, the name will be the given label prepended with the word Philip, but you can customize that if you want. You can also use these CSS attribute selectors to hook the styles off of the corresponding breakpoint. So in this example, we have a small breakpoint with a font size of 10 pixels, a medium breakpoint with the blue-colored name, and large breakpoint with bold green text. It's kind of random, but I think you get the picture. Another technique that I have used is something that I am calling responsive sprinkles. Essentially, you end up with yielding out the responsive data from the fill-up component, here denoted by F, and then sprinkling its usage around in your template. On the F object, there are these breakpoints with the labels that you've passed in, and they have a true or false value on whether or not the breakpoint is active. Maybe you recognize this example from a few slides back. The difference is that this time we don't pass in a size argument. Our greeting component already knows how to react. In this example, we only want to show the hand wavy emoji on our large breakpoint and up, and the word world on the medium breakpoint and up, and the greeting there will always be shown. Lastly, our third strategy for making responsive components is what I'm calling the component swap. The idea here is that it's actually easier to have a parent component that then wraps and swaps between the different underlying children component for the various breakpoints. For this strategy, like the others, we are defining our breakpoints on the fill-up component. We're yielding out that same F object that gives us access to our breakpoints. And then based on each breakpoint, we choose which component to render. And it's also a good idea to kind of keep parity between the arguments that you're passing into these children components. So if your greeting component accepts a model, it's good to pass the same kind of arguments down to all of the children components. So in this case, I've received a model into my greeting component. I'm passing that model along to the small, medium, and large components here. So you might be ready to go out and use container queries everywhere. You're all very excited, I'm sure. But there will still be times that it makes sense to use global media queries. Actually, in preparing for this talk, I learned that there's a speech media query, and you can actually detect when someone's using a screen reader. I thought that was pretty cool, and I'm actually quite curious to see how people are using that media query in the wild. There's also support for using media queries for how things look like when they're printed. And also, most recently, there's the ability to know if somebody has dark mode or light mode enabled on their desktop, on their OS. And so you might be able to use this media query to react and provide an experience best suited for this preference. However, I think when it comes to width and height as these specific dimensions, you probably will get a lot more use out of using container queries. I think that they will provide a more ergonomic experience in the process and probably make things much easier to test and use and reuse. So that's my 2 cents. So all in all, it turns out not much has changed, right? We still have layouts and we have boundaries, but only now we're using components to fill those layouts. By respecting component boundaries, we're able to create components that are more useful. This was true for programmatic boundaries, and I think we'll find that it is true for the physical boundaries too, large in part thanks to container queries. I hope this talk has opened up some new ways that we can think about responsiveness and the way that we build our component responsive systems within Ember specifically. I look forward to seeing what you all make, and I'm curious if some of you have already kind of used some of these techniques. Please reach out if you have some ideas. I would love to hear from you. Thanks so much.